Hello, how to solve this exponential problem? We have negative 2 to the power of t equals 2. Now, what we are going to do is, we are going to replace this negative 2 with negative 1 times 2. Remember, if you multiply this negative 1 with 2, you are going to have negative 2. So we are going to replace this negative 2 with this negative 1 times 2. So we have negative 1 times 2 raised to the power of t, and this equals 2. Now, if you have a times b raised to the power of c, this equals a power c times b power c. So you can as well distribute this exponent to each of the terms inside this bracket. That means we can distribute this t to each of the terms inside this bracket. Then we are going to have negative 1 to the power of t times 2 to the power of t, and this equals 2. Now, the next step will be for us to make use of this Euler's equation. If you have e to the power of I times pi, then this is plus 1. This will give you 0. Now, we have negative 1 raised to the power of t here, and there's negative 1 here. So what we are going to do is to move this positive 1 over here. Now, we are now going to have e to the power of I times pi equals negative 1. Now, since there is negative 1 here, we are going to replace it with this e power I times pi. So this equation becomes, we are going to have e to the power of I times pi, that is because of the negative 1, raised to the power of t times 2 power t, and this equals 2. Now from here, if you make use of this identity, you have a power n or to the power of n. This equals a power n times n. So if you apply this identity right here, what you are going to have is e to the power of I times pi t, then we have times 2 power t, and this equals 2. So now, with this equation, what we are going to do is to make use of natural log. So we have ln of e to the power of I times pi t times 2 to the power of t equals ln 2. Now, we can apply this logarithm property. Remember, if you have ln of a times b, this equals ln a plus ln b. So we apply this property right here. That means we are going to have ln e power I times pi t plus ln 2 power t, and this equals ln 2. Now, the next thing will be for us to apply this other logarithm property. For instance, if you have log a to the power of b, this equals b log of a, and this logarithm property is also applied to natural log. So the I pi t here will come behind the ln. So we have I pi t ln e plus the same properties applied here. So the t here will come behind the natural log. We have t times ln 2, and this equals ln 2. Now, you need to take notice of the fact that ln times e will give you 1. So this will give you 1. ln of e is equals to 1. So what we are going to have left is just I times pi t plus t ln 2 equals ln 2. Now, the next step will be for us to factor out t. There is t here, and there is t here. So we can factor out t. We have t, then we are going to have I times pi plus, here is ln2, and this equals ln2. Now the next step will be for us to divide each part of this equation by the same I pi plus ln2. So this eliminates this, and we also divide this by I pi plus ln2. Now we can actually have our t being isolated, so we have t equals ln2 divided by, we have I pi plus ln2. So this is our solution, and this is one method of solving this particular problem. Let's consider the second method of solving this problem. So we recall the problem. We have negative 2 to the power of t equals 2. Now, in this second method, we are still going to make use of the same first step, in which we are going to replace this negative 2 with negative 1 times 2. This is to the power of t, and this equals 2. Remember, negative 1 times 2 is the same thing as negative 2. Now, what we are going to do next will be for us to make use of this trick. Remember, if you have square root of negative 1, this equals I. Now, if you take the squares, the square root here, eliminate the square here, so you have negative 1 equals I power 2. So, remember we have negative 1 here, and we are going to replace it with I to the power of 2. So, what we are going to have here will simply be, we have negative 1 here, that is I to the power of 2 times 2 raised to the power of t, and this equals 2. Now, the next thing we are going to do will be for us to make use of log. We have log of I power 2 times 2 raised to the power of t equals log 2. Now we apply the logarithm property. If you have log of a to the power of b, this equals b times log a. So the t will come behind the log. So what we are going to have is t log I squared times 2 equals log 2. Now the next step will be for us to apply this other logarithm property. We have log a times b. This equals log a plus log b. So what we are going to have here will simply be, we have our t times, we have log I squared plus log 2, and this equals log 2. We just applied this logarithm property right here because this is in the form of log I squared times 2. It becomes log I squared plus log 2. Now, the next step we are going to take will be to divide each part of this equation by the same log I squared plus log 2, because we are trying to isolate t. So this eliminates this, and we also divide this by log I squared plus log 2. So we are going to have t left. We have t equals log 2 divided by log I squared plus log 2. Now, going by this logarithm property again, if you have log a power b, this equals b log a. So we can apply this property here. That means the 2 will come behind the log. So our t equals log 2 divided by 2 log I plus log 2. So this is our solution as well. So we have two solutions. They are all the same. Here, this one is in terms of log 2 divided by 2 log I plus log 2. Then this other one is in terms of natural log, ln of 2 divided by I times pi plus ln of 2. So ladies and gentlemen, any of the methods you can use, they are obviously very correct. And this is the end of this particular video. Please don't forget to subscribe and share this video to your friends. Thank you and goodbye.